Think math.
Draw a frequency polygon over the top of a histogram. One is angular, like a staircase, and the other runs smooth, like a ridgeline. They look nothing alike, and yet the two figures enclose exactly the same area. How can that be, when the shapes are so different? Look at a single segment. A segment of the polygon runs at a slant from the middle of one bar to the middle of the next. On the way, it overhangs the shorter bar and slices across the top of the taller one. Each bar has something added on and something taken off. Compare the piece cut off with the piece added on. Both are triangles, and both have a base running from a midpoint to the boundary, which is half a class width. Their heights are the difference between the two bar heights, and since the same segment makes both, those match too. Equal base and equal height means equal area. So they trade exactly. What the taller bar loses is precisely what gets laid on top of the shorter one. The area lost comes straight back next door. That trade happens at every boundary. So once you add it all up, nothing has changed at all. Only the two ends need attention. Add an empty class before the first one and after the last, and run the line down through their midpoints until it meets the horizontal axis. Now the polygon closes against the axis, and at the ends too, the overhang and the slice trade in exactly the same way. So the equal areas are no coincidence. The triangles fill each other in, which means the polygon encloses the class width times the total frequency, the same value as the histogram. Next time, relative frequency for comparing two groups of different sizes. See you in the next one. A sip of math every day here at Think Math.